Morning, dear students. Today we are going to discuss about your heat transfer. Okay. First of all, we will discuss what is heat. Heat is a form of energy. We know that heat is a form of energy, and heat cannot be measured directly by an instrument as temperature is measured by thermometer. Okay, we cannot measure heat directly. Okay, the SI unit of heat is joule. So let us discuss what is heat transfer. Heat transfer is a process of transfer of heat from a low temperature region to a high temperature region due to temperature difference. This is called as your heat transfer, where heat is flow from a high temperature region to a low temperature region due to your temperature difference. In thermodynamics, heat transfer is the movement of heat across the boundary of the system due to temperature difference between the system and surrounding. According to thermodynamics, heat transfer is the process of transferring heat from a system to surrounding due to the temperature difference. Okay. So again, there are three modes of heat transfer. We already discussed in previous lecture. This is your conduction, convection, and radiation. This is your conduction, convection, and radiation. These are three modes of heat transfer. Let us discuss one by one what is conduction, what is convection, and what is radiation. Okay, so conduction. Conduction is a process in which heat flow in a body is achieved by transfer of momentum of individual atoms and molecules without mixing. In case of your conduction, the transfer of heat generally takes place in a solid object. In this process, the heat is transferred due to the momentum of individual molecules without mixing between them. Okay, there is no actual movement of the molecules in an object. In an object, there is no actual movement of molecules. In case of your conduction, only vibrate at its mean position and pass energy to adjacent molecules. In conduction, again what happened? Now, the molecules is vibrate at its mean position to transfer the energy. You can clearly see in this picture. Here we supply heat to this atom. This atom gain heat energy and try to vibrate at its mean position. When it tried to vibrate at its mean position, this atom transfer its energy to the adjacent atom, that is to this atom and also this atom. Likewise, again, when this atom gaining energy and try to vibrate at its mean position, it will transfer energy to this atom and this atom. Okay. Likewise, your heat is transferred in case of your conduction to adjacent molecules. Okay. And the third point is the flow of heat depends upon the transfer of vibrational energy. And in case of metals, it depends upon the movement of free electrons. Okay. So finally, the conduction is the process where the movement of atoms and the movement of free electron is responsible for your heat transfer. Clear? Again, next we come to the conduction law. So what is the governing law by which the conduction takes place? Okay. So Fourier's law of heat conduction is the governing law for your conduction. What this law states? This law states that the rate of heat conduction per unit area, the rate of heat conduction per unit area, that is your heat flux, is directly proportional to your temperature gradient. Again, I will repeat this statement. What Fourier's law states? Now, it states that this law states that the rate of heat conduction per unit area, that is your heat flux, is directly proportional to your temperature gradient. Let us see. The Q divided by A, Q is your heat transfer, A is your area, is directly proportional to dt by dx. This dt by dx is known as your temperature gradient. Okay, temperature gradient is your dt by dx. Q by A is equal to your small q is equal to minus k dt by dx. Okay, then q is equal to minus k into a dt by dx, where small q is known as your heat flux. Heat flux. So capital Q is your rate of heat transfer, capital A is your area normal to the direction of heat flow, dt by dx is your temperature gradient, K is known as your constant of proportionality or otherwise known as your thermal conductivity. Okay, so Fourier's law states that heat flux is directly proportional to your temperature gradient. Okay, again, this what is this minus sign indicate? That this minus sign indicates that the decrease in temperature in the direction of heat flow. In the direction of heat flow, the temperature decreases gradually. This minus sign implies these things. Okay. Again, we'll see next things that what is your thermal conductivity. Thermal conductivity is the property of a material or the ability of a material to conduct heat through it. Okay, so the thermal conductivity is the ability of a material to conduct heat through it. It means that if a material of high thermal conductivity or having high thermal conductivity, it conduct heat very fast, or a material having low thermal conductivity will conduct heat at a low speed. Okay, so thermal conductivity, that is your K, indicates this term. Okay. Next is your convection. What is convection? We previously discussed there are three modes of heat transfer. One is your conduction, convection and radiation. First one will your conduction and next is your convection. What is convection? Now it is the movement of molecules with the fluid. Okay, in convection the heat transfer takes place inside your fluid. Okay. In reality, convection of heat transfer comprises of two mechanisms. That is your transfer of energy due to the random molecular motion. Second one is your energy transfer by bulk or macroscopic motion of the molecules, or macroscopic motion of the fluid molecules. Okay, these are the two terminology due to which the convection is occur. Okay, convection heat transfer may be classified nature of according to the nature of natural convection or forced convection. What is the natural convection? Now, if the fluid motion is set up by density difference caused by the temperature difference in the fluid, then the heat transfer is said to be free or natural convection. Okay. Or what is your forced convection? Now, if the fluid motion is induced by a pump or a fan or a blower, then the heat transfer is said to be your forced convection. Okay. The equation of convection, or the governing equation of convection, is delta Q is equal to H into A into delta T. Where what is your delta Q? Delta Q is equal to heat transfer rate per unit area. Delta T is your temperature difference. A is your heat transfer surface area. H is your convective heat transfer coefficient. Okay. Next part is your radiation. What is radiation? Radiation is described as the flow of heat from one place to another by means of electromagnetic waves. Okay. Next point is all bodies. We know that all body absorb and emit radiation. no medium is required between two bodies for heat transfer to take place. Fourth point is heat transfer through vacuum is called as your thermal radiation. Radiative heat transfer can be mathematically expressed by Stephen-Boltzmann law. What is Stephen-Boltzmann law? That is your Q is equal to sigma A T to the power 4, where Q is equal to heat transfer for unit time, sigma is equal to your Stephen-Boltzmann constant, A is equal to area of emitting body, T is equal to your absolute temperature. This is your Stephen-Boltzmann law. Again, we will discuss about your black body. What is a black body? Now, imagine a small body where all the radiant energy striking on the surface is absorbed and none is reflected or transmitted. Such receiver is known as your black body. We know that black body is a good receiver of energy. So, a small body where all the radiant energy striking on the surface is absorbed by the body. Okay. Second point is no physical substance is a perfectly black body. In universe, no physical substance which is a perfectly black body or behave like a perfect black body. Third point is so black body is defined as a body that radiates maximum possible amount of energy at a given temperature. A body which radiates maximum energy at a given temperature is known as your black body. A black surface are better emitter of heat radiation than a polished surface. Next point is a black body absorbs all incident radiation. Hence, it is considered as a unity. Okay. Next one is your gray body. What is a gray body? The absorption of energy by a substance depends upon its properties. High amount of energy will absorb by dark color and opaque and rough surface body. A least amount of energy is absorbed by a light color or transparent or smooth surface body. These things we have already known. At a given temperature, the value of alpha varies somewhat with the wavelength of the radiation falling on it. To solve this problem, in practice, concept of gray body has been introduced to solve this type of problem. Okay? So a gray body is defined as a body whose absorptivity is constant at all the wavelength. At all wavelength, the gray body's absorptivity is constant. Okay. And last one is your white body. What is a white body? A body is called as a white body when it reflects all radiation incident upon it. Okay, for a white body, rho is equal to 1. A black body absorbs all the radiation incident on it, or a white body it reflects almost all the radiation incident on it. Okay. Again, we will discuss about your absorptivity, reflectivity, and transmittivity. Absorptivity is termed as alpha, reflectivity is termed as your rho, and transmittivity is termed as your tau. Okay. So, what is absorptivity? It is defined as the radiation fraction of radiation energy incident on the surface from all direction that is absorbed by the surface. Absorptivity means capacity of a body, absorbing capacity of a body. So it is defined as the fraction of radiation energy incident on the surface from all direction that is absorbed by the surface. Second one is your reflectivity. What is reflectivity? It is defined as the fraction of radiation energy incident on the surface from all the direction that is reflected. This is known as your reflectivity. You see clearly in this figure. This is your reflected the rays which is incident on the surface. Some part of the rays is reflected. Some part is your absorbed inside the body, and some part is transmitted throughout the body. here is your transmittivity. What is transmittivity? It is defined as the fraction of incident radiation transmitted through the surface. Okay, so one part is your reflected, the incident radiation is here, one part is reflected, one part is transmitted, and some part is absorbed. Our next, our discussion topic of discussion is your heat exchanger. What is a heat exchanger? So okay, so heat exchanger, they are a device used to transfer heat from one fluid to another fluid. Okay, from one fluid to another fluid, by which device we transfer the heat is known as your heat exchanger. Heat exchanger can be classified into on the basis of types of fluid arrangement and method of heat transfer. According to the types of fluid arrangement, the heat exchanger is divided into three types. One is your parallel flow, one is your counter flow, and one is your cross flow. This figure is shown the parallel flow heat exchanger. What is parallel flow heat exchanger? In parallel flow heat exchanger, the hot and cold fluid stream enters together at one end. Hot fluid stream enters at this end, cold fluid stream also enters at this end. Okay, so if the hot and cold fluid stream enters together at one end, flow and flow parallel to each other in the same direction, then it is, and live together at the other end, then this is known as your parallel flow. Here your hot fluid flow in this direction and cold fluid also flow in same direction. Okay, if this flow continues or this flow happened, then this is known as your parallel flow heat exchanger. Next one is your counter flow. In counter flow heat exchanger, in this type of heat exchanger, hot and cold fluid flow parallel but in opposite direction. Hot fluid flow in this direction, whereas cold fluid flow in this direction. If the flow direction is opposite, then this is known as your counter flow heat exchanger. The hot fluid entering at one end of the heat exchanger flow path and the cold fluid entering at other end of the flow path. Okay, last one is your cross flow heat exchanger. What is cross flow heat exchanger? In cross flow heat exchanger, one fluid is perpendicular to the second fluid. Here is your cross flow. This tube, in this tube, hot fluid is flowing, and here cold fluid is flowing. In cross flow heat exchanger, what happened? One fluid is perpendicular to the second fluid. That is, one fluid flow through the tubes and second fluid passes around the tube at right angle. These are the tubes. One fluid, that is your hot fluid, flow inside the tubes. Okay, or the cold fluid is surrounded through the tubes. These are your types of heat exchanger, that is your counter flow or cross flow heat exchanger. For go through the above NPTEL link for future reference. Thank you.